Now moving on to the next topic, we have growth and depreciation. Now certain things in the world are only known to grow, like the population of India, the pollution level for Delhi, the size of a plant or the weight of a child. These things are only known to grow. So if we know the initial value for anything, how do we find out the final value, like after n years? I will tell you that. Now we have growth per year is called the rate of growth. First of all, this R is the rate of growth, which is the growth per year. Now if this rate of growth is constant, we can use the exact same formula as we used in compound interest to find the value V after n years. Now this formula has R as the rate of growth per year, N as the number of years as we had in compound interest. Now V here is the initial measure of the quantity, like the initial weight of a child when it is born is 10 kgs. So this is the initial weight. What is his weight after 2 years? That will be the final weight, and the end there would be 2 years. So V naught is the initial weight. V is the measure of the quantity after n years. So this is the final measure or the final weight of the child. This is how we can find out any value of anything that grows at a constant rate, right? So now moving on to depreciation. What is depreciation? Certain things in the world are known for its decrease in value, like cost of a machine or cost of a vehicle. These things are, the value of these things always reduced due to wear and tear. So there the formula changes to V naught into 1 minus 1 R by 100 raised to power n. So this plus sign is replaced by the minus sign. Rest everything remains the same. V naught is the initial measure of the quantity, which will always be more than V. The V is the final measure of the quantity after n years. N is the time, and R is the rate of depreciation this time. And again, this formula is only valid if the rate of depreciation is constant. So R is the rate of depreciation, V naught is the initial value, V is the final value, and N is the number of years. Now what if we have different rate of interests for different depreciation or growth rates for different years? What do we do then? The formula remains the same as in compound interest. V is equal to V naught into 1 plus R1 by 100 into 1 plus R2 by 100 and so on. So this formula will be used if the rate of growth and the rate of depreciation are different for the different years. So we have, for the same for depreciation, we have V naught into 1 minus R1 by 100 and 1 minus R2 by 100. So this thing remains the same. The formulas are exactly same as in compound interest. Now we will move to some questions.